Question 2. So this reaction is redox reactions between the iodide and the H2O2 with the help of hydrogen ion, and the iodide will oxidize to iodine from -1 to 0 oxidation number, and the H2O2 will reduce to H2O. So the oxygen's oxidation number is -1 here, and it will become -2 after the reaction. So this is the redox reactions again, okay, between the iodide and H2O2. And a student carried out a series of experiments to investigate the order of reaction with respect to the concentration of iodide ion. And the student does this by measuring the time taken for the fixed amount of iodines to form. A known amount of thiosulfate in the reaction mixture reacts with iodine and reduce the iodine back to iodide. So the thiosulfate now has one function. It's used to delay the formations of the blue-black, because once the means from the reaction, once the iodide oxidizes to iodine, the thiosulfate will react with the iodines that form, and this iodine will reduce back to iodide, which means with the presence of the thiosulfate, we will not see the blue-black yet. We will see the blue-black when the thiosulfate reacts with the iodine. So that's why here it says that any further iodine form is detected using starch indicator. Means once the thiosulfate reacts, the extra iodine that form will combine with the starch, form blue-black. This is a reaction. So it means the redox reactions which involve these few species of these few compound. So now these following materials are used. So Ki with this concentration and this volume 250, 0.1 mole per dm cube Ki. Thiosulfate is 0.1 mole per dm cube. H2O2 is 0.1 mole per dm cube. The acid is 0.2 mole per dm cube. Starch and water. So these are all the reactants that involves. Part A. A second student look at the equations for reaction 1 and state the order with respect to the concentration of iodide ions. So it must be second order, because the balance equation contains 2 iodide. Again, let's get back to the equations just now, means reaction 1. So from here we can see there are 3 reactants: iodide, H2O2, and the H+. And now the student just simply make the conclusion, say that iodide must be second order because the coefficient here is 2. So this is not proper, because in order to identify or to get the order, we cannot get from the coefficient. We can get from the rate determining steps and the experiments results. So that's why this one suggests why a balance equation alone cannot be used to determine the order. So because not all the reactants may feature in the rate determining steps. Means in this reaction, there are 3 reactants. So these 3 reactants might not really appear or in the slow step or rate determining step. So maybe 1 or 2 reactants here will be involved in the rate determining steps. So that's why we cannot just simply say that iodide is second order, right? Okay, so again, very important, only reactants in the rate determining steps will give the order. We can get the order of the reactants from the slow step or rate determining steps, and depends on how many particles that involved in the steps. Okay, so that's why this is the answer. Or more accurately, you can say that the order of the reactant we can get from the experiment. So means we compare a few experiment sets and we can get the order. Part B. Describe how students mix 250 cm³ of 0.1 mole per dm³ Ki, starting from the same the sample of solid potassium iodide in the 50 cm³ beaker. So now, it's better for you to calculate the mass of the Ki that involved. So how to calculate? First, we need to get the mole, because we need to prepare 250 0.1 mole per dm³. So therefore, we just use mV over 1000, so we get this mole. This is the mole of Ki that needed for the preparation. So times its molar mass, 166, we get 4.15 gram. So the mass that needed to prepare this concentration with this volume, okay, it will be 4.15 gram. Okay, so therefore, the first step, you better put dissolve 4.15 gram of Ki in 50 cm³ beaker using small amount of distilled water. Okay, distilled water is very important. Don't simply just say water. Distilled water is used to prepare solution. Okay, after that, once it's dissolved, okay, let's say this one, put distilled water, okay, and let the solid dissolve. After that, we transfer the solution into the volumetric flask. Okay, so transfer the solution to 250 cm³ volumetric flask. So because in this the instruction, okay, it actually needs you to put the name and the size of the apparatus. So you just follow. So the name is volumetric flask and the size is 250 cm³. Okay, after that, you need to rinse the beaker here with distilled water and transfer the washing to the same flask here. After that, you need to top up this 250 cm³ volumetric flask to the calibration mark somewhere here with distilled water also. After that, invert and shake the flask to homogenize the solution. This will be the full preparation for this solution. Okay, part C. The student carry out experiment 1 using following steps. So we have step 1 to step 7. I make it faster and simple. Step 1, 2, 3, 4, 5. Okay, they are all the solutions that needed, and all these solution going to put in the conical flask. Okay, so means now the conical flask has H2O H2SO4, okay, H2O, Ki, sodium thiosulfate, and the starch. So all the 5 solutions in these 5 steps. Okay, after that, step 6 is what? Is use a burette to add 10 cm cube of 0.1 mole per dm cube H2O2 into the small beaker here. Okay, so after that, we pour the H2O2 from this beaker to the mixture in the conical flask. Once we pour H2O2, then it will start the reaction and reacts. Okay, so after this H2O2 mix, start the timer and stop the timer when blue-black form. The blue-black will not form first because in this mixture it has thiosulfate. The thiosulfate, it will delay the formations of blue-black. Once the thiosulfate here is finished, then the blue-blacks will form because the iodines will combine with the starch, okay, to form the complex. Right, so this is the how the things works, or how the reaction works. And after that, the student carry another 6 experiment. So means now total 7 experiment with the, okay, the difference is what? So difference is actually this. So difference on this volume of the distilled water and Ki actually is the Ki. So the volume of the Ki is the one that changing. So the volume of Ki, it can represent the concentration of the iodide. More volume, then the concentration is higher. Okay, so now let's move on. For part 1, how the student could improve the reliability of the experiment. Okay, very easy. So if let's say the student want to really try, okay, let's say experiment 6 is accurate or reliable or not. So the student may use the same amount of the reactant, let's say all this volume, same volume, and do it again. If the student can get, let's say around 59, or let's say get 60, which is very close to this time, then is very reliable. Okay, so just repeat the experiment to show the results, okay, which are reproducible, whether it can produce back or not. Part 2. State the independence variables in these experiments 1 to 7. Independence is always the one that we can change, or we can always fix the volume, or we, let's say in this one we can use 5 cm cube, we can use 7.5, we can use 10. This is the one that we can change, or we can actually use 9, depends on us. Okay, after we change, then the time that taken will change too, right? Okay, but in this part is asked independence variable, means the one that we can change, so it's obviously the volume of Ki. Okay, in experiment 5, this one, the starch indicator change color immediately on adding of H2O2, and the student realized it must have something, it must be an error there. So what is the error? So the error, it must be the one that involve thiosulfate. Means in the okay, throughout these steps, so which step is the one that caused that error? So is step 4. because step 4 is the addition of the thiosulfate to the conical flask. So means the student actually forgot to add this thiosulfate into the mixture. Yeah. So it must be step 4. Right. Okay, so because you say that suggest which step was missed in the experiment 5, it must be step 4, because step 4, okay, is the addition of thiosulfate. Okay, again, thiosulfate used to delay the formation of blue-black. Without thiosulfate, the blue-black will form immediately. That's why it must be step 4. Okay, part D. The rate equations is represented as this one. The rate equal to the K constant times the concentration of iodide power n. So n is the order. The order of the iodide in this reaction. And now is given log rate equal to log K plus n times log concentration of iodide. So this is the one that we're going to use for the graphs, and we'll discuss later. And these are all the relation. N is the order. Okay, rate is proportional to 1 over t. T is the time. Okay, part 1. Use the result from the student experiment in part C. Okay, this one, part C. Okay, means for this one, the time and the volume. So complete the table 2.2. So this one is very easy. You just try to calculate. Next year is 3SF. Calculate and 3SF, you can get the full marks. Right? Okay, so this one, the V is the volume of Ki. Here, V is the volume of Ki. So this one from experiment 1 to 7, okay, volume of Ki, and this is a time, okay, from the previous table. Okay, so log V and this log 1 over T, so you calculate that. So you should get all this value in 3SF. Okay, after that, you try to plot the graphs. Use the values and try to plot it, right? Okay, so this one, okay, I make it a bit smaller. So these graphs, okay, after you plot, you get one anomalous point, right? So try to draw a best fit. Okay, you should get something like this. Okay, this is the anomalous point at this log V equal to 1.10. Okay, so now from here we know that this is a log 1 over T, means the rate, versus log V. Log V is actually the volume of Ki. Volume of Ki is direct relate with the concentration. Okay, so 5 cm cube, 10 cm cube, and so on, right? Okay, now therefore we know that the log V is actually the log concentration of iodide. So means the gradient here, if you calculate gradients, okay, so the gradient will be the order. So you can get the order from this gradient. So now part 3. A timing error caused the most anomalous point on the graphs. Circle this point and explain the error in timing, which led to this point. Okay, timing means we just focus on this log 1 over T. Okay, so from here you should understand when is okay, this one is the, okay, when it's going down, moving down, so we know that the time is going to be longer. This is from the data. So means when it's going down, the time taken will be longer. So means this plot will be the longest time means in the table it will be this one, the last one. Oh, sorry, this is the first one, longest time, the first plot, this one. Okay, so means this one is the longest one and this one is the shortest one. Okay, so the key is when the log V is 1.10, means this one. So in this best fit line, it's actually the log 1 over t value is supposed to be around here. So means theoretically it should be around here. It should be a shorter time taken. So means this abnormalness is because of what now? It's because of the longer time taken. Because longer time taken, then eventually this will be lower than the best fit line. So why is longer? So this is the reason. The time recorded is too long because the timer stopped too late. So the student stopped the timer later than the one that expected. Right, so that's the reason. Okay, so after that, use your graph to determine the gradient of the line of best fit. Okay, this one you just, again, you choose the two. Okay, after you draw this best fit line, make sure you get two coordinates from the line. So for mine, I just choose these two coordinates. You can get yours, right? Okay, so calculate, you should get around 1. So for mine, I get 1.11. Okay, so after that, so means actually gradient just now I told you, right, is the order. So the order is actually first order. Okay, the last part, total percentage error from the measurements is determined to be 5.25%. Okay, the true order of the reaction is 1. Okay, use this and your gradient from the D part 4, means the previous one. Okay, to determine whether the error in the experiment could be accounted for by error from measurements or caused by other factors. So now we need to calculate the error first, right? Percentage error of the experiment value. Okay, so it's given theoretical is this 1. What we get is 1.11. So use the experiment results minus the theory, and after that over the theory times 100%. The percentage error of the experiment value is actually 11%, which is larger than this, the one that given. Total percentage error that given 5.25 means now we have the extra error. So therefore we know that other factors might contribute to the experimental error. Means not just this one, others also. Others, what is that? We need to identify if it's us, right? So that's all for this question. Thank you.